Okay. Again, just so we get it, so you have reference to it. 2 to the 1/2 is not undefined. It's a perfectly good number. You just can't write it down. It's close to 1.4. It's about 1.414, but nobody can tell me what the next digit is, and I'm not sure. Okay? And there's no end to the digits. You can't write the number down. We don't use it in drawing the basic graphs. We don't need it. Okay? But it's not undefined. Now, if you marked it as undefined, that's no big deal. I certainly wouldn't penalize that at this point. But we just don't use it. If we got to figure that out, don't bother. Okay. And the function that does that is just the exponential function, which has a really clear trend without that number, right? If you did the graphs, I'm not sure everybody did the smooth graphs there. We'll catch that next time. Okay. Now, for the pendulum, okay? What's wrong with this graph?
It would reach 0 and it can't.
I'm sorry?
It would hit 0 and.
Yeah, it's going to hit one of the axes or both, right?
Yeah.
Okay? And probably for a positive number. And if it hits the axis, that means either the count is 0 or the length is 0, right? Okay? And if you got a length of 0, well, it's a little hard to figure out what happens as length shrinks down towards 0, right? It could approach some number. So that could actually be plausible, but you're never going to have a length where the count is 0. Any pendulum is going to oscillate more slowly if they get longer, right? So that's what we talked about last time. That's a very good answer. Okay? So the x-intercept of this graph implies a length for which the count is 0. That can't be. That doesn't correspond to reality. Okay? That's what we said last time. Okay, so let's, how about this one? Anything wrong with that one? Well, what happens to the count as the pendulum gets longer?
It gets lower. It wouldn't
The
get.
count gets lower. A longer pendulum,
It wouldn't get faster.
less count. You did that, right? And I've seen, both from my distance class and from a couple that I've seen in this class, where people kind of got that backwards. Okay? Not so much in this class, because we actually do the picture. In the other class, I kind of left that. I didn't tell them anything. I said one length is 1, the other length is 3, so they just put down 1 for the one with the lesser count and length 3 for the one with the greater count, which was misleading, right? And there's nothing wrong with that. Yeah, of course, I emailed the person back and said, hey, you can still get full credit, but think about this. Okay? You know, letting him figure it out. Okay? So, longer would be in this direction, right? And greater count would be in this direction. Well, longer doesn't go with a greater count. So the graph can't look like this, right? That doesn't match reality. Ah, Beethoven. So, I mean, I like Beethoven, but I get a little tired of that one. It's one of my favorites. So. Okay. There we we go. Okay, let's see. What's another possibility? How about this?
It implies that it would get faster toward like, the longer.
Yeah, well, one thing you could say is, past this point, the count is increasing for greater length, right? So because of what we said here, longer can't imply a greater count, right? And there's another problem with this. Problem is, if I draw a horizontal line through these points, I have this point here and this point here. Okay? Now what's wrong with having 2 points directly across from each other?
It would indicate they have the same amount of.
The what now?
They would have the same amount of swings.
Yeah, you'd have 2 different lengths that have the same number of swings, right? Okay? So,
Wouldn't that still be a function now?
I'm sorry?
Wouldn't that still be a function now?
It's what now?
Wouldn't that still be a function now?
It's a function, but it's not a function that applies to the pendulum. At least not that aspect of the pendulum, right? Okay? So I'll say that's legal for a function. But doesn't match pendulum reality. Okay? And there's another aspect of this. Got to put this in a different color. This function's not 1-to-1. Okay? By 1-to-1 you mean you have exactly one count for one length, for each length, right? Okay? Got the wrong word there. Now that doesn't mean it's not a function. Okay? There's some functions that would give you the same result for 2 different x values, but not a pendulum count versus length, right? Okay, so let's see. What's wrong with this?
Lengths repeat.
You'd have 2 different counts for the same length, wouldn't you? So this would show you everywhere along this line it's the same length because, you know, it's going to intercept the x-axis at the same point, right? It's going to have the same x-coordinate everywhere along that vertical line. So you have 2 different counts for the same length. Okay? And that pendulums don't act like that. Not going to be part of our pendulum model. Okay? So we can say count versus length is a function. Every length has just one count. Okay? And it's 1-to-1. Every count corresponds to exactly one length. So I said every count corresponds to just one length. Okay? We understand those statements about a pendulum, right? These are general characteristics of a function. To be a function, every y, every x has exactly one y. You don't have two different y's for the same x. You don't have two different counts for the same length. Okay? Now, a function doesn't have to be 1-to-1. Okay? But 1-to-1 corresponds to just saying that every count corresponds to just one length. Okay? Got it? Well, pretty much. These important characteristics. Okay. What about domain? What's wrong with could that point be on your graph? Why not?
Negative length.
That would be a negative length. You can't have a negative length, right? Okay? No such thing as a negative length. Okay? Also, there's no such thing as a zero length, right? So, length has to be greater than zero, so that your domain is, I'm going to use set builder notation, it's a set of x values with a property that x is greater than 0. Because we're using x for the length, right? So it's a set of all x's with the property that x is greater than 0. That's what this notation means. It's an important notation. There's no better way, nobody's thought of a better way to write this condition. Okay? Now there's another way to write it. You could write it as an interval, open interval from 0 to infinity, right? Okay? Now theoretically, if you had a uniform gravitational field all the way out to infinity, you would have a pendulum of any length, right? Practically, that would be difficult. And also, since gravitational fields are an inverse square thing with masses, There's no such thing as a uniform, an infinite uniform gravitational field. Can't be. Okay, not in this universe. Okay, another thing is, why can't it be here?
Negative.
Can't have a negative count.
Can't have a negative count. Counts start at 0, right?
That'd be cool though.
Huh?
That'd be cool though.
Yeah, you can think about
I'd
that.
pay to watch.
Yeah, it's studying functions of complex variables. That's what I specialized in. Study them till you know more than I do, which is feasible. Yeah, it might take you a while. It took me 7 years after high school. And
But I can't have them this long. So I feel like I'm scratching.
see what you think about that. Or just have fun speculating on it. Okay? You know, speculate. Okay, so. So I'm going to say the range is restricted to positive y values. Okay? That's what that says. You can look at the video and read it because it'll be clear in the video. Okay? Because if you're sitting in the back, you know, I can't even read it when I write it. I don't know. Okay. Make sense? That's the idea of domain and range. Now, there's a lot here in just this example about properties of functions, and also in what makes sense when you're trying to model something that happens out here in reality, right? And that's probably the most important thing you learn, how to use functions to model reality. Most important thing you're probably going to learn in this course. Okay? So we got to develop some algebra, we got to develop some properties, and we're just about out of time, so we'll kind of go from there, right? A lot more I could say, but I want to make sure you understand this. Okay? In terms of these models. Now I'll get an assignment up there. Like I say, I got to go deal with the water heater, but I'll get it up there by this evening. And if I can't get it onto your, I don't have access to my webs. I'm the only one on campus that doesn't have access to my webs. They just stopped working, and it's a Microsoft thing, and nobody can figure it out, including Microsoft. So everybody else has got webs they can write to. I've got to be here to put anything there. And I'm probably not going to make an extra trip up. There's no long trip. I'm probably not going to make an extra trip up here because there's probably other things I need to do. So I might have to email it. And hopefully when I do, I'll email it to the right year. Okay? So if you don't get an email by tonight, somebody email me and say, hey, where's our assignment? Okay? Okay, very good.